Hello, ladies and gentlemen. My name is Volker Thome. I'm head of the Department Inorganic Materials and Recycling at the Fraunhofer Institute for Building Physics, IBP in Germany. In this video, I will show you why the energy used to create buildings is playing an increasingly important role when assessing global warming potential. We will show the advantages in terms of material efficiency with AAC constructions which I've used in Chennai. In addition, we will give you an insight into the research activities at our institute and show how we manufacture AAC. Finally, we will show what potential there is to make autoclave aerated concrete even more climate friendly. In the previous videos in this module about the lighthouse project in Chennai, you've already learned a lot about a precast concrete construction system in general and how it is applied in Chennai. We discussed already how we could improve different aspects of the building construction, like for example the energy efficiency, durability, or also the comfort in the building. Now, in the last video of this module, we will focus on future development potentials, especially regarding the use of AAC blocks and how we can produce and use them to build in a more climate-friendly way. Climate change and global warming have led topics such as the ecology movement to become the highest of priorities in recent years. The building materials field is also strongly affected because of its huge extent and its great demand for energy and raw materials. Consequently, material efficiency is a very important level of consideration here. Let's go into more detail. In the previous videos, we looked at reducing the global warming potential in the operational phase, which you see here in the green bar. We have tried to reduce this bar as much as possible. All measures referred to the operation of the building, for example, the cooling or heating energy demand. With the measures shown, we were able to reduce this bar to a minimum. In this way, we have increased energy efficiency. With a more energy efficient building, we see that the share of material efficiency in the blue bar takes a higher share in comparison. Material efficiency assesses the energy required for material production and assembly. In other words, the energy that is consumed before the operation phase. And what we see is the more energy efficient the building is, the more influence has this material regarding the construction and demolition phase. AAC blocks were used for the buildings in Chennai, as you can see on the upper picture on the right hand side. Let's now look at what AAC is and how it should be evaluated in terms of material efficiency. Autoclaved aerated concrete, it's called AAC, is a lightweight cellular material which has a great potential for use in sustainable buildings due to its environmentally friendly properties such as an excellent thermal insulation and lower embodied energy compared to other building materials such as ordinary concrete and bricks. Moreover, it provides an opportunity for the application of byproducts and waste materials such as rice husk ash in large quantities. On the lower picture on the right hand side, you can see, for example, AAC specimens using rice husk ash as a silica source. At the Fraunhofer Institute for Building Physics, IBP, we are continuously conducting projects to further improve the properties and also the life cycle assessment of AAC blocks. In the next step, I will guide you through the production phase of AAC blocks as we do it at our institute. The main components used to produce AAC are quartz sand as a silica source, lime and cement as a calcium source, and a small amount of aluminum powder or paste as a foaming agent. However, almost all of the current produced AAC contains sulfate carriers, to regulate the setting of the mixture and improve the properties of this material. In addition to quartz sand, byproduct materials such as rice husk ash can be used as a silica source for AAC production. Using rice husk ash in the AAC mixture can increase sustainability of AAC products considerably by reducing energy consumption in production process and improving materials efficiency. These ingredients are then mixed with water in a defined way. The final step of AAC production is autoclaving, which includes the hydrothermal treatment of AAC mixtures at elevated temperatures, typically between 180 and 200 degrees Celsius, and a corresponding pressure of about 9 to 14 bar in a saturated steam condition. The autoclaving process is necessary for establishing the conditions under which the formation of the so-called tobamorite mineral can take place in AAC. Tobamorite is the mineral which is responsible for the compressive strength in AAC. In general, the autoclaving process is an essential step in the production of AAC as it affects the product properties significantly. AAC is an extremely porous material that is mainly composed of air. This fact provides its main favorable property, especially the excellent thermal insulation property. In general, the AAC volume is composed of 27 to 83% volume of air pores and 17 to 73% of volume of solid matrix, or so-called solid structure. The air pores are generated due to the reaction of aluminum powder under an alkaline condition and the formation of hydrogen gas as the reaction product which can generate the air pores. These large air pores, which are defined as roughly spherical pores, has a diameter of about 100 microns, and the solid matrix around of these air pores consists of solid material and mostly irregular pores, which are referred to as micropores. In another word, the solid matrix contains another part of the total porosity in its microstructure, which makes up from 13 to 41% of the total volume. Okay, we use aluminum powder as a foaming agent, and if you mix cement together with water and the other ingredients, we generate an alkaline solution, and finely ground aluminum reacts in this alkaline solution with water by releasing hydrogen. So this hydrogen gas is the actual foaming agent which generates this porous structure in AAC. This is quite similar like the process we use here in our lab. What you see here in the back is the smallest possible oven size, which can produce the same type of AAC like in a big oven. So these big ovens means they have a length of about 30 meters for industry. But basically we mix 5 ingredients together, which you can see here. We use cement, we mix it together with finely ground silicates, limestone, gypsum, and using an aluminum powder as a foaming agent. And aluminum reacts in the water, which leads to the foaming of the AAC. And first of all, we generate a so-called green body. So we have to establish a so-called green body strength. And after a few minutes, we can then demold this dog and put it into the oven. And then the real hardening reaction takes place at hydrothermal conditions at 180 degrees and a pressure of 12 bar. Yes, of course, we can produce various kinds of autoclave tolerated concrete depending on the density and the porosity. For example, if we optimize the density, we could build houses with about 2 flats with this material. Or we can say, I want to have a pure insulation material. Then we can even establish a density of 100 kilogram per cubic meter. And this has a heat conductivity similar to expanded styrol. but has the benefit we don't need any flame retarders, and it's a non-burnable material. So it's a perfect insulation material, which indeed then leads to an energy saving in the house.